Okay, welcome back everyone. So today we are going to learn a new topic. So as you know that we've finished sets, so now we're going to start the next topic, which is relations. Okay, we're going to start relations now. So let's start with relations. So basically, what are relations? Okay, what are relations? So let's have an introduction here. Okay, an introduction to relations. Introduction to relations. Okay, so it is the study. Okay, it is the study of Cartesian product of sets. Okay? So this is what it is. It is the study of the Cartesian product of sets. Okay, that's what relations is. Sets. So the Cartesian, let me just correct this. Cartesian, okay, that makes this Cartesian product of sets. Now, it's basically, so this is what it is. So, to understand the Cartesian product of sets, let's talk about an ordered pair. So, what is an ordered pair? What is an ordered pair, guys? So, an ordered pair contains two elements given in a fixed order. Okay? An ordered pair. Okay? My apologies, guys. My apologies, okay? So, an ordered pair contains two elements. It contains two elements in a given fixed order. Okay, so that's what it is. So let me give you an example, guys. So okay, let me give you an example. Okay, so I'm going to give you an example right now. So okay, so let's say that, okay, for example, let's say A is an element of AB and B is a element of and B is an element of AB. So so if A is an element of AB and B is an element of AB, then that means the set AB is an ordered okay. So basically then the set A and B is an ordered pair. Okay? Okay, so the set A and B is an ordered pair. Okay, so I hope you understand this so far. So what we're going to do is we're going to move ahead now. I hope you understand this so far. So let's really move ahead. So now we're going to talk about the Cartesian product of sets. That's what we're going to do. So let's really talk about that. The Cartesian product of sets. Oh god, guys. Wiping the board can sometimes be so difficult. Okay, so now we're going to talk about the Cartesian product of sets. Okay? The Cartesian product of let's assume set A and B are two non-empty sets. Okay, so let's assume A and B. Okay, A and B. Okay, are A and B are two non-empty sets. Two non-empty sets. Okay, so let's assume A and B are two non-empty sets. Then every ordered pair, every ordered pair is the Cartesian product of sets. Okay, so this is one thing that you should understand. Okay, so this is one thing that you should understand. Just keep this in your mind. Okay, let's say A and B are two non-empty sets. Okay, then every ordered pair. So, guys, reason why I keep on reading this again and again is to make sure I've written everything properly and it's making sense and I've not left anything out. You know, sometimes you have to write like this and write. So I just want to make sure I've not left anything out. So now there are a couple of things you have to note down. Okay, and these are the rules. Okay, these are basically the rules. Okay, so you have to just understand this. So let's now look at the rules. So let's try and understand the rules. I'm going to explain the rules to you, so don't worry. If you don't know the rules, it's basically impossible to even understand the ratios. You know? Okay, so just note this down. Very important. These are basic rules. Okay. So if A, okay guys, if A is a empty set and B is an empty set, then A times B is an empty set. Do you understand? If A is a set that contains no elements and then B is a set which contains no elements, then obviously guys the Cartesian product of A times B will then also be an empty set. Okay? You know, that's rule number one. Okay, so this is the first rule. So let's look at the second rule. Okay? Okay, so okay, my apologies guys, my apologies here. If A is an empty set of B, then A and B is okay. So now if you see, that's why I proofread everything again. Okay, so if A is equal to null set and okay, and B is equal to null set, okay, B is equal to null set, then A times B is also equal to null set. We also remember guys, although this is common sense, this will tell you also A times B is not equal to B times A. Okay? That's just for your knowledge. So, like I said, if set A is an empty set because it doesn't contain any elements, and B is an empty set because it contains no elements, then A times B again will be an empty set because it's not going to contain any elements. Okay? So let's look at rule number 3. Okay. Okay guys, if set A has m elements, okay? Has m elements. Okay? And set B has n elements. N elements. Has n elements. Then A times B will be equal to m times n. Okay? So do you understand? So I'll give you an example. Say set A has 3 elements and set B has 2 elements. Then A times B will be equal to 2 times 3, which will be 6. As simple as that. Not something which is too hard or does not make sense. Okay, so now let's look at the fourth one. Okay? Okay? If A and B, okay? If A and B are non-empty sets, A and B are non-empty sets. And either A or B, okay? Neither A or B the A or B is an infinite set. Okay? It's an infinite set. It's an infinite set. Okay? So is A times B. Okay? So just remember all this. You can put a full stop if you want. It doesn't really matter. Okay? So basically, what this means is what this means is that if A and B are non-empty sets, and either A or B is a infinite set, then the Cartesian product of these two sets will also become an infinite set. Okay? That's practically what it means. Okay, now I've written these down, I've explained it, but I hope you can read this properly and it's visible till the bottom. I hope that. I definitely hope. Yes, there's absolutely no problem here. So, let's really move ahead. Oh god, guys, I just got ink on my clothes. But anyways, it's okay. Other people don't even have clothes to wear. And I'm crying that I've got ink on my clothes. Very sad. It's fine. Other people don't even have clothes to wear. And I'm crying that I have clothes to wear. That is sad. Anyways, let's move on. I'm not going to let my wisdom, get the best of you. I do like to preach sometimes too much, but I'm working on it. Okay, I'll leave that for you to decide if I was joking or not. But anyways, let's move on. But yes, when it comes to mathematics, I won't leave it to you that I'm joking because I know I'm serious. So let's move on. So basically, okay, A is equal to B. Okay, then if A is equal to B, then A times B is expressed as A squared. Now this is very logical, guys. This is very logical. It's common sense, guys. Okay? You can have two sets. And both those sets, can be assumed by A. So A can equal, say, maybe 1, 2, 3, and another set can be equal to maybe 4, 5, 6. So then these two sets can become A times A, and then you can just multiply both of them. This is practically what it means. And it can be for any number of elements. It doesn't have to be a 2 times 2 or a 3 times 3. It can be for any number. So don't get confused like that. Don't assume anything else. So now this is the sixth point, is it? Yes. Okay. So we can also describe ordered triplets, okay? We can also describe